Okay, so here is number 9. So it's the volume of a cube with length x. So this is what they don't really do a very good job describing. Is the sphere is this one right here. It is this black line. And we're supposed to find the volume of a cube. So we can go into Desmos and get points. Let me just remind you of how to do that. So I did not push that button. There we go. Ding, ding. I don't know what's going on. Done. Okay. Delete all. So we want to type in here x squared. And I'm going to be able to do it right here. Cubed. X cubed. And I want to get 2 points. And here's a nice thing also about this problem that you can do to make this easier. This says right here, this interval from 1 to 2. So to make this easier, what we're going to do in Desmos, so we have one that's x cubed. The other one that we're going to add in is we're going to do x equals 1. So like from this to x equals 1 and x equals 2. And then we're going to see where they intersect. And it helps us get some points. So we have our x cubed. We have x. Why does this obsessed with that? Okay. X equals 1 and x equals 2. And we can get those points by clicking, right? So once we have those two lines, we can click to see where they cross. So we have 1, 1 and 2, 8. Okay, 1, 1, and 2, 8. And then I think on Savas, you can go in and put those points in. But on the paper, I'm going to go like this and label it. That's the point 1, 1. Oops, 1, 1. And then 2 is clear over here. And then 8 would be about right there. There's 2, 8 right there. So then the curve on just this part would go like that. So the question's asking, which one is increasing faster? So increasing, all this is like, we're looking at basically what is the slope, which slope is steeper. So if we looked at those 2 points, or if we did it with the other one, it would be somewhere like up here, and it'd be pretty steep, right? Like really steep. So which one has a steeper slope? Well, it's going to be the black line, so it is the sphere because it's steeper than the one that we just graphed. Okay, number 10 is it says to do this with synthetic division. I'm going to make a totally separate video of synthetic division. Okay, we're going to do this again. So this is for number 10. We have this big long problem. We're dividing it by x minus 2. I am just going to double check that all my numbers are correct. X minus 2 equals minus and then plus, plus, plus. Okay. And then I'm just going to double check. Minus and plus, plus, plus. Okay. Good. So x times by what equals x to the 4th, and that would be x to the 3rd. X to the 3rd times negative 2 is negative 2x. These two combine to be negative 5. So if I have negative 2 and I want negative 5, I need 3 more negatives. So we have, and it would be x cubed right here, an x cubed. All right. So that was round 1. Round 2. What do we have to multiply x by to get to negative 3x cubed? We'd have negative 3x squared. Then negative 3x squared times negative 2 is positive 6x squared. And these two would have to combine to be positive 2x squared. So we have 6. We want only 2. We're going to have to take 4 of them away. And so then x times by what equals negative 4x squared? Well, that's negative 4x. Oops, I went too far. So with that color, negative 4x. Then negative 4x times negative 2 is positive 8x. And then we want to get to 6. So what would we need to do to get 6? Because we have 8, we want 6. We're going to have to take 2 away. From there, 2 x's away from there. And so then x multiplied by what would equal negative 2x is what we're doing next. So it'd have to be negative 2. And then negative 2 times negative 2 is positive 4. And so now we're out. Well, okay, now those two would have to combine to be 6. But now we're out, right? So I want 2, but this right here would be my remainder. And then, so what we do with this remainder is we're going to take this, sorry, my cat was messing with things and I was trying to write remainder. And so that would be plus, because that's a positive, 2. And then we're going to take this, what you divided by, and put it underneath this fraction. Sorry, he's trying to get pet and messing me up. Okay, so it'd be that. So that's the first time we've seen that fraction part. It's not that difficult if you understood the remainder. You're just going to put whatever the remainder is underneath the number that you divided it by. So it's all of these terms. So x cubed, negative 3x squared. So yeah, let's see. So we have the x cubed, negative 3x squared, and then it was negative 4x. And then it was minus 2, and then this 2 over x minus 2. Okay, and now this is describe the behavior at each 0 for this one. Oh, did I include that? Yeah, identify this. Oh, describe the behavior at each 0. You can, if you need to see this, you can graph it and look and see how it looks in a graph in Desmos. Or if you remember, if it's an how we described it is if it was an odd power, it crosses. And if it's an even power, we're only looking at the exponent, it's going to just touch there. But you can go and graph, and you can see that that's what happens. So our 0 is, so at 5, remember those are the opposite. There it's going to cross. And the other one is at 1, and at 1 it's going to touch. So if you look at our options, 5 is cross. So touches at 1, yep, touches at 1, crosses at 5, it has to be A. Number 12, you can also graph this. You're supposed to identify the zeros, and those are opposites. I'm just going to tell you because it's pretty easy. If it's just x, it's 0. You take each of these factors and set them equal to 0. So the first factor being x, we would make it equal 0, and then that is the 0. If we had x minus 1 equals 0, we could add 1 to both sides, so it'd be positive 1. And then, remember, it was the opposite thing that we did. So then same thing, if we had x plus 2 equals 0, we would subtract 2. So x would be negative 2. I should put here x equals positive 1. So negative 2. You can also graph them and look and see where it crosses the x-axis. I'm going to pause here. 13, notice that there are all these options. It's multi-select, and not all of the terms of the binomial are done. So yeah, we're going to do this in order. We're going to expand this binomial theorem using the same thing that we did on number 3. Going to expand this using the binomial theorem. It's the same thing we did on number 3. If you don't remember it, that's okay. So I'm gonna start by doing the binomial theorem, the Pascal's triangles. So we start with a 1, and then 2 1s, and then 1, and then 1 plus 1 is 2, and then 1, and then another 1, and 1 plus 2 is 3, and then 2 plus 1 is 3, and then 1, and then we want to go to the 4, right? So then 1, 4, 6, 4, 1. So we're going to write those out. 1, leave some space. 4, 6, 4, 1. And I'm going to move this one over a little bit because we're going to need that space. Okay, then we take the number on the left, so this 3a, and we're going to put it to the power of 4. So 3a to the power of 4. Then 3a to the power of 3, and we're going to keep on going down, right? 4, 3, 2, 1. So this is 3a squared and 3a to the power of 1. Then we take the 1 from the right and do the same thing from the right. So this will be 3b to the 4, 3b to the 3, 3b squared, 3b to the 1. And because this is actually kind of a nicer one, I think, compared to number 3, because there's the plus there, then all of these in between here are going to be a plus. They're all separated with a plus. Last time I didn't do that until we calculated. But these are all positive, so I just put it in there. Okay, so then you're just going to be doing calculating. So you can calculate 3 to the power of 4 in a calculator in Desmos, and it would be 81a to the 4th. We can do the same thing with the one on the right side. We're going to use that same skill. It would be 84b to the 4th. Now, if we're looking at the answers for this one, because we can, oops, where is it? Right here. Notice there's nothing with to the power of 4, and there's no 81s. So that means that everything we're focused on, oh, there's an 81, but it's not to the 4th, so it's definitely not this one, right? So it's probably going to be the guts of the problem. And let me just look and see if there's any other hints. Nope, okay. Okay, so let's keep on going. So then we would have to use a calculator to figure out what 4 times 3 cubed times 3 is. So I'm going to do 4 times 3 cubed by 3. Delete all. Happen here. 4 times 3 cubed times 3, and we get 324. So then we get 3. Now the a is to the 3rd power, but the b was just regular, like no power. Then we're going to do 6 times 3 squared times 3 squared. So that's going to be, I don't know why it's obsessed with zooming in so fast. Okay, 6 times 3 squared times 3 squared is 486. 486 a squared b squared. That was this one right here. Like it lined up right there. And then I'm going to be doing 4 times 3 cubed again, which is this. I don't know if you can see the numbers on these two are the same. So I don't have to do the number part, but the variable part's different. So we're still going to have 324, but now it's just going to be regular a and b cubed. So the number with the a cubed and b is 324. And then 324 goes with the b cubed. And then it's 486 with the a squared and the b squared. So it's up right above us. So 486 with the a squared and the b squared. There wasn't one that was just plain a. And then it was both versions of the 324. So there we go. Those are the 3 middle terms. Okay, last one. How does this graph of 2 and then x cubed minus 1 differ from the graph of its parent function? So you'll need to know what a parent function is. That's basically this function without any adding or subtracting or multiplying to it. So in our case, it is x cubed. So we can come back into Desmos and we can type that in. We can do 2x cubed and then minus 1. And we want to compare it to the parent function. So the parent function is just x cubed. So first, from the purple one to the green one, we're just going to focus on what that looks like. From the purple one to the green one, it's down, right? You can see that it moved down. So for sure we have a down. And you probably remember from the other vertex one that we did on quadratics that comes from the minus 1. So let's just look and see what that 2 does on the green one. So I'm going to put my cursor here next to it, and then watch. I'm going to take it off. See, there's no 2. There is a 2. No 2. There is a 2. What would you describe that is? as? Like what's happening to it to make that happen? I would say, well, and what the thing is it is a vertical stretch. It's like you're grabbing onto the top and the bottom of that graph and pulling vertically to stretch it out. So it is, yep. So the graphs are definitely not the same, right? Not the same. Subtracting 1 did not do anything about moving it right. So like what in the heck, right? It's not that one. The leading coefficient 2 stretches it vertically. Yes. Yes. And then there was no subtracting 3, so it has to be that one also because subtracting 1 moved it down 1. All right, so that's the whole test. Hopefully these videos helped.